All right, today we're doing something a bit different, something special. This isn't your typical explainer. We're going to walk through a really tricky piece of work, a solution to a problem that's been around for a long, long time. So let's just dive right in. All right, Sahil, this one is for you. Jai wanted me to put this together to give you a crystal clear guide to this pull request. The code changes he's proposing. This thing finally cracks a really tough nut. So yeah, think of this as your personal tour of the fix. So let's talk about the mission. And honestly, calling it a mission is not an exaggeration. The whole goal was to crack GitHub issue number 1594. Sounds technical, right? But what it really means is letting sellers add funds to their Gumroad balance. Why? So they can cover refunds if their balance is low. Seems simple enough, but oh man, this problem was devilishly complex to actually solve. Okay, so what makes this a real detective story? Well, this issue is basically a cold case. Seriously, before Jai's solution came along, there were three, yeah, you heard that right, three previous attempts to solve this, and every single one of them got blocked. So if we want to understand why this one worked, we first got to look at why the others failed. All right, let's look at the evidence, the cold case files. The first attempt, just abandoned, ghosted. The second one was a bit of a mess. The user experience was clunky, you couldn't even update a credit card, and, this is a big one, it used foreign keys. Basically, it created these rigid links in the database that the Gumroad codebase just doesn't do. It's a big no-no. And the third try, it was split into 3 different PRs, which is messy, it was missing tests, and get this, it was missing a video walkthrough, just like this one. So you can see the traps we needed to avoid. So, the big question is, what made this attempt different? Well, here's the secret sauce. Before a single line of code was written, there was a deep, deep investigation. Jai set an AI agent loose to do something he calls code-based cartography. Think of it like creating a detailed satellite map of the entire massive Gumroad codebase. The goal was to understand every single road, every connection, every dependency. And how did this whole investigation start? It kicked off with this one simple but seriously powerful command. That one line sent the AI agent burrowing deep into the entire application, just mapping everything out to build a complete picture of how it all fits together. Now, you might be asking, why was this map so important? Well, you have to get a sense of the sheer scale of this thing. The agent found 293 different models. That's basically the DNA of the business logic. Then it uncovered 247 controllers. Think of those as the front doors handling every single request that comes in. The place is massive. But this next one, this is what really blows my mind. Over 1,100 lines in just the main routes file. That's a tangled web of connections that you absolutely cannot ignore. And to top it all off, there are 177 different background jobs chugging away behind the scenes. See, this complete map shows exactly why those other attempts failed. You can't just slap a new feature onto a system this complex. You gotta know the lay of the land first. So once we had that deep cartographic understanding, that's when the breakthrough happened. The agent generated a master plan. And I'm not talking about a rough sketch on a napkin. This was a full-blown, comprehensive blueprint, engineered from the ground up to avoid every single one of those previous failures. And this is the brilliant part. Look at these success criteria. Each one is a direct counterattack on a past failure. Remember the split-up PR? Bam! This plan demands a single comprehensive PR. Remember the bad user experience? Pow! A separate form with its own save button. It required full card management. Create, read, update, delete, the whole shebang. And the big ones? Absolutely no foreign keys, and it had to have complete end-to-end tests. This plan was literally designed to succeed where others failed. Okay, the full technical plan is a lot, super detailed, but we can boil it down to these 6 main phases. It's a really logical bottom-up approach. You start with the foundation, the database layer. Then you build up the walls with the models, put in the plumbing with the services, and you just keep building layer by layer until you get to the very top, the front-end component that the user actually sees and clicks. Just a rock-solid way to build. Okay, a great plan is, well, it's great, but it's nothing without execution, right? So now, let's do a quick-fire tour of the actual code that brought this plan to life. This is where the magic happens. This is where the case gets closed. First stop, the database. A brand new table was built just to hold these credit cards. And look right there, in all caps, no foreign key constraints. This was non-negotiable. It follows the existing Gumroad way of doing things and completely sidesteps the exact landmine that blew up PR number 1736. It's smart, it's consistent, it just works. Okay, next up, the balance load model. This thing's job is to keep an eye on every single attempt to add funds. And the key piece of tech here is the state machine. The best way to think about it is like a super strict bouncer at a club. It makes sure every transaction follows the rules. You start as pending, no exceptions. From there, you can only go to successful or failed. That's it. This means there's zero ambiguity. We always know the exact status of every charge. So you're probably wondering, where does the credit card actually get charged? Right here. It's all handled by this one thing, a service object called the charge service. It neatly packages up all the messy logic for finding the right card, talking to Stripe, and making the payment happen. It's just a super clean and organized way to handle such a critical step. And that brings us to the front lines, what the user actually sees. This new React component creates a totally separate section in the user settings just for managing these cards. It's got its own form, its own save button, the works. And yup, you guessed it, this is the direct fix for that awful user experience that helped kill PR number 1736. It's simple, it's intuitive, and it doesn't interfere with anything else. Perfect. So at this point, all the pieces are built. They're tested. They're integrated. There was just one thing left to do: officially close the case and ship it. Let's watch the final moments of this mission unfold. First step, get add. All the new and modified files, 13 new, 5 changed, all staged and ready to go as one single cohesive solution. Next, the commit message. It's beautiful, it's clear, it's concise, and it points right back to the issue number it's fixing. The whole story in one line. And then, the final step. Git push. And there it is, success. The code is up, the branch is live, the pull request is ready to go. Mission accomplished. And that, my friend, brings us to the end of the walkthrough. What we have here is a solution that didn't just ignore the past, it learned from it, building a really robust and comprehensive feature that's ready for the future. So Sahel, it all comes down to you now. The final question is simple. Ready to review?